Fancy meeting you here at the Daily Space Weather. But in any case, thanks for joining us here at the Smash News Network, least busted name in news. Whew. Let's get back to space. We've got new sunspots. There's one right here that may get a name if it doesn't completely evaporate. Also, a new one up here. If those do get names, they'll be 3069 and 3070. 3068 right here has consolidated some of its umbrae a little bit. Here are the magnetic fields, the solar magnetogram from the SDO. And what about some composite imagery? Here's 211, 304, and 171 angstroms. Covered a crazy coronal mass ejection yesterday. And we're expecting another small CME strike today. We'll get to it. The 10.7 centimeter radio flux, well, we'll get to that too. First, volcanoes. Karimsky is still erupting in an explosive fashion. That's an uptick there on the Kamchatka Peninsula. Karimsky now producing a 26,000 foot plume of volcanic ash, flight level 260 over Kamchatka. Sakurajima exploded as well, flight level 070, 7,000 foot ash plume from Sakurajima. Going down to Colombia and some other South American volcanoes. Nevado de Ruiz there, I think that's an uptick at Nevado de Ruiz. It's exploding. It's a flight level 250, 25,000 foot ash plume. In Ecuador, we've got Sangay and Revenador. Sangay, 20,000 foot ash plume. Revenador, 15,000 foot ash plume. They're both exploding. And last but not least, Sabancaya down in Peru, 27,000 foot ash plume as Sabancaya also explodes. Don't pole vault the caldera. It's a flight level 270. Taking a brief look at global seismicity here, no major quakes over the past 24. Some in the 5 magnitude range, at least one. But pretty calm here, seismically speaking. So the South Sandwich Islands, looks like 3 5.1 magnitude quakes here. One 50 minutes after 0 hour this morning on the 31st of July. 5.1 at the South Sandwich Islands. 2.5 hours later, a 5.1 at Nepal. And then about a half hour after that, a 5.1 at Indonesia. That was more like an hour and a half later, I should say. So 3 5.1s there in a period of about 4 hours. Tonga saw a deep quake at a 4.6 magnitude, 234 kilometers estimated depth there. Philippines saw a 5.0. That one happened at 5:50 this morning on July 31st. And there is the rest of your list for the last 24 hours. Now, looking at our house favorite wavelength here, and showing you the most detailed imagery you'll find on the internet of the closest star. Here's a close-up of sunspot 3068. A couple active regions rising here in the east. We'll see if they're sunspots. Let us know in the comments what you think, if they'll be sunspots or just plages. The radio flux now down to 91 solar flux units. Oh my God, we're all going to die. The sun's going to shut down. By the way, folks, we've got like 2 more years until we see solar maximum. We're nowhere near solar maximum yet. So fasten your safety belts. The hot part of the sun will be back. And at the Smash News Network, least busted name in news, we'll cover it. Again, radio flux now at 91 solar flux units. There's the 1-year chart. That black line is the 1-year graph of the 10.7 centimeter radio flux. It comes from the upper chromosphere and lower corona. And it's proportional to sunspot number. Space weather enthusiast dashboard not expecting any CME strikes. Oh, maybe it is. There's a geomagnetic unrest forecasted here, although we haven't seen it happen. We are expecting another CME strike, so it could come at any moment. sometime throughout the day today, possibly another small signal tomorrow, because we saw several CMEs that may have had an Earth-facing component in the past couple days. Here's the earthly geospace out to about 12 Earth diameters for the past 4 hours, modeled by the Space Weather Modeling Framework. This is magnetohydrodynamic pressure, nanopascals. If you want to view it yourself, you can go to the Space Weather Prediction Center. It's the Geospace Magnetosphere movie. Geomagnetically calm conditions at the moment. Next, ground magnetic perturbations. Also the last 4 hours. Some minor magnetic pulses there coming out of the equatorial portion of the planet. And this imagery is great at showing you the likely places where we would see aurorae, induction into power grids like power lines, railways, pipelines, etc. That's the last 4 hours of ground magnetic perturbations in nanotesla magnetic flux density. KP index at 2. Again, geomagnetically calm conditions, nothing exciting going on there. Let's take a look at the real-time solar wind after we look at the GOES magnetometers. And there are the GOES magnetometer readings over the past 3 days. Fairly smooth here. Nothing too exciting going on there. And what the heck? Where did the real-time solar wind go? We need the real-time solar wind, folks. What happened to it? It's vanished. Somehow we've missed that. All right, so here we are, real-time solar wind. We may have seen a small CME strike yesterday. If so, it would have been this area right here, around 1800 hours universal time. You can see this small signal right in here. A little uptick there in the solar wind speed, and you can see a change in the plasma temperature there on that bottom green line. That could have been a small CME strike. A little bit later than we forecasted, it was moving pretty slowly, but a little bit faster than the underlying solar wind signal. Anyway, current conditions are about 12.7 protons per cubic centimeter for the solar wind density, solar wind velocity, about 350 kilometers per second. Again, expecting another small CME strike today and another one tomorrow on August 1st. Here's some more magnetic data for you. It's the top view ecliptic plane field plot. And one thing about the solar polar field reversal process is the South Pole is moving more quickly than the North Pole. So the North Pole is still largely oriented at the north heliographic region. That's our top view ecliptic plane field plot. This data derived from 51 ground-based magnetometers and magnetometers on stereo A out here at Lagrange 5 and stereo B here at Lagrangian point 4. So here's your line of sight field plot. And again, the south solar polar field, a little bit ahead of schedule in terms of its relation to the north solar polar field. And we do have some North Pole coronal holes rotating in, some great close-ups of the South Pole ones. We'll get to it first. Cosmic ray update. Cosmic ray flux at a Patity neutron monitor down over the past 30 days, although up slightly over the past week. Staying in the far north cosmic ray monitors, Barentsburg also down over the past 30 days and up over the past week. We'll also look at Athens, Greece. We show 7 cosmic ray monitors regularly on the channel because they're reliable cosmic ray monitors that don't show lousy-looking data. Keep in mind, folks, it's easy to have tainted data. With your neutron monitor, these are all fairly believable. We've been showing these on the channel for years. So there's Athens, showing a similar graph there, down over the past 30 days, up over the past week. We'll go even farther south to Mexico City, about the same graph there, down over the past 30 days, up over the past week. Going back north to Oulu, Finland, about the same graph there. I would note the historic graph. If any channels on YouTube are telling you that we are at the cosmic ray maximum, well, we're down here. And the highest cosmic rays ever measured happened around 2010, way up there. So don't believe it. We cite facts on the channel, not fear-mongering nonsense. Anyway, there's Oulu. We'll also look at DOMB Antarctica. Reliable sources show corroborative data. And also staying as far south as we can get, DOMC Antarctica. There's DOMB, there's DOMC, down over the past 30 days and up over the past week. Next, our line of sight coronal hole plot. And we showed that at that point in the video because, well, coronal holes are kind of like cosmic ray sources. You could make the argument that the high-speed protons from coronal holes are cosmic rays. And we've got some North Pole coronal holes rotating in here on the eastern limb. You can see those in green. And we'll show an extreme close-up of this South Pole-oriented coronal hole system down here. That's 193 angstroms. You can also see a CME happening up here in the northwestern limb. See that plasma ejecting here in a moment. That imagery is the last 24 hours from SDO. So here's a close-up of that coronal hole, and you can almost kind of infer that there are protons blasting out of there from the way that plasma's undulating. It's a very lively image there. Great imagery there of some South Pole-oriented coronal holes. Next, we'll move to sunspots. Again, we've got some possible newly named groups here. So this group here, it's only an alpha class sunspot. I think there's only one umbra there. It may be named Sunspot 3069. I think it has been exhibiting umbrae for more than 12 hours. And this one up here, barely showing some umbrae there. When we did show prep, that one might be 3070 if indeed this one gets named 3069. 3068 is the real story, though. It's grown a little bit in the past 24. Here's the magnetogram for the past 24 hours. And here's the continuum. These images all SDO, Solar Dynamics Observatory. You can see that umbra still rotating a little faster than the trailing umbra of North Pole orientation, the leading umbra South Pole orientation, and again, that leading umbra consolidated a little bit. You'll be able to see it a little bit better in our close-ups. So there's the southern hemisphere. And it looks like that Sunspot 3069 is hanging on. I think it's going to get a name today. It's only alpha class at the moment. Its likelihood of producing major flares not that high. This area here could produce some flares. And let's take an extreme close-up of 3068. There you go. There's the magnetogram. Spectacular imagery there of polarized light. And here's our continuum view. Again, you're going to see some umbral consolidation happening there in that leading portion. Migration and consolidation of the leading umbrae. Pretty sweet. And let's continue on. There's a lot more stuff to cover today, like the GOES X-ray flux. So no major solar flares here. Just minor B-class intensifications, like this tiny little B flare here, a B 3.7, happening at 2200 yesterday. Here's the 131 angstroms wavelength. That is some very, very hot iron in there. No relativistic particles to speak of on the GOES proton flux. If you're up before dawn, you may see Venus, the third brightest object in the sky. And Venus is in Gemini right now, which means, oh my God, Venus and the Earth are going to switch orbital positions and we're all going to die. There's going to be a runaway greenhouse effect. Oh, noes. Just kidding, folks. The planets aren't going to kill you. But if you are up before dawn, you may see Saturn, Jupiter, Mars, and Venus all across your early morning skies. How about a solar system forecast? Keep in mind this chart is not to scale. Those planets are very, very far apart from each other. Here's your 1 week forecast. Here's where things will be. On August 7th, we will have a gibbous waxing moon in a week's time. Now, we are missing some data here from the George Mason University Space Weather Lab, so we can't show you those coronagraphs, but we can show you the ones from Stereo A and the Soho-Lasco C3. So from the perspective of the Soho-Lasco C3, the Earth would be behind you. From the perspective of Stereo A, Earth would be approximately off on this line. And we do see a CME here. It looks like it's out of the western portion of the sun here and not earthly directed, if I had to guess. It may look like it's somewhat earthly directed here on the Stereo A coronagraph, which is missing about 4 hours of data there. But I don't think there is an earthly component with that. We don't see a halo, so we're going to assume that it is not earthly directed. There's that huge CME we covered yesterday. That was on the far side of the sun. And you'll find lots of tweets about that if you follow the space weather community on Twitter. And if you haven't answered our poll about accountability on Twitter, twitter.com/smashomash. It's still pinned to our profile, twitter.com/smashomash. If you can tolerate the pathetic censorship of the platform, go answer the poll. Next, our El Teide, Spain ground-based solar observatory here. This is hydrogen alpha imagery, 6,562.8 angstroms. And not nearly as many filaments as we had a week or two ago. Some filaments down here in the southern hemisphere, though. Remember, folks, we don't need sunspots or coronal or solar flares to see coronal mass ejections. The plasma can eject without any solar flares happening. So things pretty calm here at the moment. Don't worry, folks, the hot spot on the other side of the sun will be back. And it will get exciting. So we've got some CME activity actually happening here as we stream the video. Great imagery there from the GO 16 SUVI. And let me just check the life of the stream here. And everything looks AOC. All right, so that's what's going on. That's ionized helium. And you've got a wider field of view there from the SDO and a little bit less resolution. Here's a demonstration. There's a little higher resolution and a little narrower field of view from SDO. Same wavelength, still ionized helium. A little bit more detail. And that is the last 24 hours of solar activity. Moving on to our bonus feature segment, we see some minor charging hazards here over the West Mexico, moving into the Central Pacific Ocean. Those are caused by low-energy electrons building up on the surfaces of satellites. No major expectations of communications disruptions from that. Here's the GO 16 and 17 relativistic electron measurements. For the past 3 days. They use radiography to measure the GOES electron flux from their geosynchronous near-equatorial orbits using radiography. Here is the NOAA forecast. Expecting a little downtick there in the electron flux. There's the one-year chart from Solon.info. We'll show the F ionosphere layer, the bridge between Earth and space. Here's the vibrational frequency of that layer of the ionosphere. The F layer is located at about 300 kilometers of altitude. We do see some significant anomalies here, mainly of the low frequency variety. We'll get to it. Here's the anomalygram showing anomaly in megahertz from the 30-day median. You can see some significant low frequency anomalies there, especially around the equator. Some over North America as well. And some rapid swings happening here around the Middle East. You can see some high to low shifts happening right around there. Right around the Arabian Peninsula, Persian Gulf, and northwestern Africa. Anyway, here are the latest images. That is 10:30 Universal Time ionogram. There's the 10:30 Universal Time anomalygram. Next, we'll show the total electron content forecast. It's going to show you the most likely places for GPS errors. We'll let it play all the way through a second time here. We're seeing fairly low electron counts throughout most of this, actually. And most people who live around the equator are aware that their GPS will not work well, especially around noontime. So fairly low electron counts there on the total electron content. Feel free to pause the video on this frame. Keep in mind distances are shown here in miles. There is the latest intensitygram and latest colorized magnetogram. Don't be surprised to see some flaring from this area down here. Although it is an alpha class sunspot, meaning it's only got one polarity umbra. If you look at the fields there, you can see it's only got one umbra. But there is some active area here around it, so that could indeed produce some flaring. The real story is sunspot 3068, but there may be a sunspot forming up here as well. It doesn't look like it at the moment. So there's a plage for you. We'll have to keep an eye on that to see if it grows or shrinks. And there's sunspot 3068. And that leading umbra is about the size of planet Earth. How about one more composite image? I like the 171 plus colorized magnetogram. And there is the full disk view. That is yesterday and today so far. And we're going to have to close out this space weather video and move to the realm of meteorology. So it's time to chew bubblegum and cover weather from a global perspective. And I'm all out of bubblegum. So here is the highest wind area on the planet. And it looks like the winds have actually diminished here since we did show prep. We were showing 70 mile per hour. There we go. We still have 70 mile per hour winds. If you're wondering where it's located, it's off the coast of Mexico. Hurricane force winds there in that low pressure system. Those are the surface winds. And let's check out the east side. And shout out to our viewers from all around the world. There's what's going on in the most populous portion of the world, which is right about here. That including India and China. There are a lot of people on that part of the planet. Next, 250 hectopascal winds known as the jet streams. We got a jet stream breakdown here in between Australia and New Zealand. Looks like New Zealand is getting some cold temperatures there. Strong jet stream here on Western Australia. Fairly incoherent jet streams here in the Northern Hemisphere. Here are the jet streams of the Americas. Totally incoherent jet stream over the U.S. In fact, it's blowing backwards all the way from Florida to Baja California. Check it out. And this strong anticyclone we've been covering for days now in the North Atlantic, continuing to rotate clockwise as anticyclones do in this hemisphere. So this will create some funky weather and some very unfortunate weather for Kentucky. Here are the surface winds of the Americas. And here are the surface winds of Europe, Africa, and the Middle East. Last but not least, the jet streams of this side of the planet. We've got lots more meteorology stuff to show you. First, station identification. Here at Smash Tube, least busted name in YouTube. Because we're just not busted at all. We just cite facts, not biased, cherry-picking crap. Press like and subscribe if you enjoy the content. Thanks to our new subscribers. Tell your friends and foes about us. Press share. Press the notification bell. You never know. You may actually know, due to notifications, when we put up content. Thanks to all of our viewers. Today's featured product is Mensa. Make Earth Not Suck Again. It's up to you. Not giant bureaucracies that can't get out of their own way. Think global. Act local. And the products are extremely high resolution. Start a conversation about how to make Earth not suck again. It's one of the purposes of our channel. To do things like make YouTube not suck again. One more reminder, folks. Our finest days lie ahead. Links below the video to that. And if you'd like to support the channel via subscription services, consider becoming a Gold or Silver Smash Team members. Thanks to our Gold and Silver Smash Team members, the best value is the Gold annual paid-up subscription. It's equivalent to getting 4 months for free because it includes complimentary merch and an actual free month. Smashomash.com/SmashTeam. Additional perks for those at paid subscription levels. Once again, thanks to the Gold and Silver Smash Team, we will be bringing our credit crawl back like we did when we were on Patreon. We still are on Patreon, actually. Again, look for our credit crawl coming back soon. Welcome to the Neo Renaissance. You can find the links and more, such as a permanent invite to our Discord chat, at smashomash.com, our homepage. We were inspired to create our own websites because of pathetic censorship on Facebook in 2018. By 2019, we had it. And we didn't launch the Smash Team site until October of 2021 officially. Once again, thanks to all of our Smash Team members, especially Gold and Silver paid subscribers. We've got some dry, windy conditions in Hawaii, some gale warnings around the Aleutian Islands and the Alaskan Peninsula, excessive heat in the Pacific Northwest, and some flooding in Nevada, California, New Mexico, Arizona, and unfortunately, in Kentucky. We want to see the rains subside there, but unfortunately, not happening at the moment. Let's bring up a 72-hour GFS forecast here. We'll show that in just a minute. Just give that a second to load here. We are on tropicaltidbits.com, and here is your 72-hour GFS pressure. Not pressure. Total accumulated precipitation in inches. Again, another inch or so of rain expected in Kentucky, Tennessee, West Virginia, and some heavier rains there in places like southern Alabama. Maybe as much as 4 inches expected down there. Also isolated areas of Mississippi. Anyway, that's your GFS total accumulated precipitation map for the next 72 hours. You can expect that to be a fairly accurate forecast indeed. Next, your NASA Goes Lightning Mapper. We've got some strong lightning here right on the coast of North Carolina. And let's check our real-time lightning map. We've got quite a bit of lightning here once again. We've got some terrestrial lightning here in South Dakota. That is a fairly unpopulated area, but there's where the lightning strikes are happening. We love checking it out when we hear thunder. Lightningmaps.org. And since the video was streamed live, thanks to our Twitch followers, twitch.tv/smashomash, make sure you install the mobile app. It'll actually alert you when we go live. And let's take a look at temperatures around the planet. That's what's going on. It's not looking too hot in Greenland, even though it's light mostly all day long, all day and night. Although summer is abruptly coming to a close. Some very hot temperatures here in places like the Middle East. Saudi Arabia looking a little bit on the warm side. South America looking a bit on the cold side. Yowzers. Anyway, that's your temperature map from windy.com. Here's your radar.weather.gov map and some snow returning to the high mountains of Alaska. Cincinnati getting some rain, and some showers on the way to Minneapolis. As we record, here is your whoops. This is the Smash News Network, least busted name in news. And we're going to show you the shortwave radiation map as well as the water vapor map. Get those loaded for you and get them onto your screen. So here's the shortwave radiation, 3.9 nanometers. Showing clouds and fog, and you can see the evidence of the jet stream blowing backwards here, as you can see some upper level clouds moving east to west. Rapid cloud nucleation there off the coast of North Carolina. Here's your recap. U.S. Doppler radar. Ground-based systems that show vertical motion of water droplets in the air column. Satellite imagery showing clouds and fog. Infrared radiation. And one big cell of clouds there moving across Oklahoma as we stream. And thanks for tuning in. Congratulations on realizing the channel exists. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted name in news.